Hey guys, so it's not for you, but for me, it's 4th of July. So I thought I'd do something a little patriotic. Yesterday, what happened was I did a simple little like update so that I could um, show, so that I could update the bold or the font, and that went really well. But then I got caught up in promises. Um, I'm kind of lucky because I worked during a time before observables and after promises, so I got to spend hours and hours and hours and hours on promises. And these sort of promise thing concepts come up in interview questions, and I feel like literally 99% of people that answer the questions correctly just have the question memorized. They don't actually understand it, and it does. They don't understand it. The reason it's so hard to understand is because it doesn't make any sense. It's like it's a really it's there was a problem, and the problem was that it used to be that in JavaScript you would want to move like animate things or something along those lines, something that needed to happen a lot, and then the code that we had to be able to sort of accommodate animations was blocking. It would basically run the code, but the problem was that while it was running, all the rest of the processes were completely stopped, and it made for like these really jaggy weird animations. Like there was this time when like they had these animations that would follow the mouse around, like if you're doing this, and there would be like a bunch of unicorns or hearts or something following it around. I'm glad those days are behind us. But that these sorts of animations were blocking, and what would happen was that it would get like bumpy. It would be all jagged as things. So they had to come up with like a non-blocking solution. So they came up with promises. And the reason that like if you start off on the back end or some other kind of coding, typically it's fine to do blocking coding. Like I'm working on learning back end for my new job, and there's all kinds of places where we just block the code because on like a restful call, that if you add a tenth of a second, that is no big deal to the call. But if you add a tenth of a second to an animation that's moving on the screen, your eye processes that at 60 frames a second. So adding a tenth of a second is going to be clearly obvious, and it's just going to feel wrong. So this is really like so. Anyways, let's just look at this code. So I have the promise all. This will only execute when all promises have been resolved, all the font promises. Then here I say, okay, in this font process, once it's resolved, which it is, then run this code. And so this is console log number 2, run that code. And that should work. And it doesn't even matter. I would actually move it out because the font item is going to exist because the font item exists because it resolved. I should have put this up here under here, but that doesn't make a difference. And then I say, if this font promise is resolved, run this code. Same thing. That is that resolved? Then run the code. And fourth, the promise all this code is done. So theoretically, what should happen is console log 1 should go, then console log 2, console log 3, and console log 4. Now you probably, if you're into this kind of video at all, you know that it didn't work that way. What happened was 1, 4, 2, 3, and you have that memorized, and good for you. That's awesome. Uh, Seriously, no sarcasm, all respect. And sure enough, all promises have been resolved. 4 end of resolve promise runs, and you can't actually count on these to run in order, but they did in this case. So 1, 4, 2, 3. When you would have thought it had been 1, 2, 3, 4. So I asked ChatGPT, and then right after I asked the question, I said, why does code in the next part of resolve promises execute after the following code? I didn't even mention JavaScript, right? But so this is very, very unique to JavaScript, and this is not, I don't think, anything you would ever learn in school, because it's not. It's an edge case. It's a very specific thing to JavaScript. Um, I don't know if Python has this or some other. It would definitely be something that would be very specific, I think, to um, scripting languages. I don't think this would be something that you would have in compiled languages. But yeah, it's an edge case. It's a weird thing. And so then it says when you work with JavaScript promises. So like it knows exactly what I'm talking about. You might notice the code following the then or catch method often executes after the code that comes in the process promise resolution. This behavior is due to the JavaScript event loop handles and microtasks. So there's this movie I love called Starship Troopers, and in there there's this scene that always reminds me of computer programming where these two experts are arguing, and one of them says that the bugs, humanity is at war with these bugs from outer space, and the bugs might have intelligence, higher level intelligence. And he goes, bugs with brains, that is offensive, right? This event loop concept is extremely offensive to most developers. And the reason I think it is because if you've ever done any schooling at all on code, you at some point decide to make a loop and run code during that loop, and that had some sort of interfacing with a file or interfacing with the UI or something. And when you did that, you got hammered. You got the smackdown. It's just part of learning about programming. They are against looping. And so this JavaScript event loop is basically all JavaScript runs on a loop. It runs exactly like that thing that the teachers told you not to do. It looks for work, and then it loops through all that work. And then when it gets done, it goes and looks for more work and loops through it. It just iterates round and around and around in a circle. At least that's a good way. That's a way I sort of visualize it. So event loop and microtasks. Okay, so this is where a lot of people just sort of dip out. JavaScript runs in a single threaded environment, meaning it can execute one piece of code at a time. However, it uses an event loop to manage the execution context, which allows it to handle the asynchronous operations efficiently. So they're saying right here that offensive thing. It's running in a loop over and over and over again, and it's interacting with the UI. It's interacting with files if you happen to be in Node. It's interacting in things you're not supposed to do. It's doing exactly what you got the smackdown in college for, or in school for. Promise resolution. When a promise is resolved or rejected, the callback attached to it via then or catch is placed in a microtask queue. The microtasks have a higher priority than other tasks, but they are not called execute immediately. So this is a very fancy way of saying it's pushed to the beginning of the next loop. So it's going through the code, pop, pop, pop. It's popping off instructions, and then it finishes all that, and then it runs across a promise then call. So like in here, when it hits this, it's popping off, and then it hits this then call, and this pushes it to the beginning of the next event cycle. Okay, execution order, the main code execution. So this right here, when this promise all happens, the first line of code it gets is this one. Then the next line of code it gets is this one. Then it pushes this execution off to the next cycle. It's done. It's over. It's not going to happen. Then it pushes this one. It runs this line of code, and then it pushes this code to the next cycle. And then it runs this one, and then it runs this console log 5. And so basically that is why you see this happen. Now what would be really nice is if there was a way that you could like see what the count is. It would be millions, right? Like it's running these things at like 100, 200, 300 times a second. So every second one of those loops fires off. But if you could see, you would see that these two ran off in the same execution loop, and then these two ran in the next execution loop. That's why, and a set timeout's the same way. It gets pushed to the next execution loop. So what I could have done was I could have done like set timeout here, set timeout. And I could have even set the timeout to 0 seconds, and that would automatically push it to the next execution loop. So then this one would run, then this one would run, then this one would run, and all my problems would have been solved. So anyways, the execution order is the main code execution. So this is main code. Microtask queue, after synchronous code is done, the event loop checks the microtask queue and executes the tasks there. So actually it's not the next, okay, I might have been wrong on that. It might be pushed to the end of the loop to this microtask queue. I actually don't know when this microtask queue is fired. So anyways, and then he gives some examples, ChatGPT gives some examples and kind of gives you something very similar to this. So here's a good example. Let me see. Let me hit Control minus. So this is kind of a thing where it says, hey, this is the main queue. Well, resolution of promises happen here. I don't know. I guess I don't think that's a good one. This is a good one. This is actually associated with a talk that I watched years and years ago. It's a very, very good talk. So if you ever see this picture of a talk, it's a good talk. But I think it's a long one. I think it's like 35 minutes. But basically what happens, I think this is the microtask queue, and I believe this is the request animation frame. So basically it runs code, runs code, runs code. If it pushes, so this line of code right here would push this code into this task. So if this is open, it runs that code afterwards, but it would run this code and this code, the line 144, 145, 156, 167, 168 as part of this. So it'd be pop, 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 pop. Then it would push all these lines here and all these lines here over into this thing. Then it would get to that thing. And then if it had to update the screen, it would do that over here. I believe that's how that works. And it tries to do this little yellow thing 60 times a second so that your eye, if it misses like on the queue, it might do this 400 or 500, depending on the speed of your CPU, it might do this a couple hundred times a second, 500 times a second, something like that. And then once every 60 seconds, it tries to do this, or 60 times, once every 1/60th a second, it tries to do that. I don't know. That's just how that works. I think it's an important concept to understand. Whenever I start a new job, a lot of times they'll have like bugs around that have just been around forever. I'd say 1 out of 3 times it's something a lot that I can fix on day one, and it usually has something to do with this concept here. As you saw in last video, I very rarely get it right the first time. I almost always have to poke around and get it right. And then I quite often don't explain this very well in an interview. There'll be some sort of question along these lines, or they'll show something like this, and they'll be like, "What's gonna execute first?" This is kind of one thing I'm a little bit better at doing than explaining, but that is my latest attempt. This video is 13 minutes long, so it's not too bad. I was expecting to look up and see it was like 25 minutes long. And that's that. I didn't do any actual work on the project in this video, mostly because I thought that this was a really great opportunity to sort of explain a very difficult concept. And I don't even know if it should be considered a concept. It's more of a side effect. I think if we could go back in time, and they probably should have at least checked to see if this was resolved before they decided whether they were going to run this code or not. I think it's silly to just automatically push it to the next and just assume that it's not resolved when the developer calls it, because this is a perfect example where it's already resolved and then it ends up running in a weird way. So that is that. And one other thing we learned is that you really can't put blocking code in the constructor, which probably makes sense. Which, like, when you put async await, you're not technically blocking, but you're preventing the code from running cleanly all the way through. So that's that, happy coding, everybody. Bye.